We have learned plane control survey before. So today we will learn elevation control survey. Elevation control survey is the work of measuring the elevation of control points. It is divided into National Elevation Control Survey and Route Elevation Control Survey. What is National Elevation Control Survey? The National Elevation Control Network is mainly established by precision leveling method, so the elevation control network is also called leveling network, and the elevation control point is also called leveling point. According to its different accuracy, it can be divided into 1, 2, 3, 4 levels. The first leveling network is the backbone of the National Elevation Control Network. The second leveling network is laid within the first leveling ring, which is the comprehensive basis of the National Elevation Control Network. The third and fourth leveling networks are further encrypted. What is Route Elevation Control Survey? The Route Elevation Control Survey is the elevation control survey work carried out for the small area engineering construction to meet the needs of mapping work. The Small Area Elevation Control Network is also established by grading method according to the size of the survey area and the requirements of engineering accuracy. The main methods used are 3 and 4 leveling surveys and triangular elevation surveys. Today, we will focus on learning the common methods of elevation control measurement, 3 and 4 leveling surveys. First of all, let's look at the technical requirements of 3 and 4 leveling surveys. 3 and 4 leveling surveys should generally be based on national or city high-grade leveling points, and 3 and 4 leveling lines or leveling networks should be laid in the survey area. If there is no national high-grade leveling point in the survey area or nearby, an independent first-level elevation control can also be directly established according to the 3 and 4 leveling survey methods. According to the National 3 and 4 Leveling Survey specifications, in engineering construction, the main technical requirements of 3 and 4 leveling survey observation work are: taking 4 leveling surveys as an example. 1. The instrument is DS3 leveling instrument. 2. Use double-sided ruler. 3. Sight distance length, 100 meters. That is to say, the distance from the instrument to the rear viewpoint and the distance from the instrument to the front viewpoint cannot exceed 100 meters. 4. Line of sight height, 0.2 meters. 5. Forward and backward sight distance difference, 5 meters. The rear sight distance minus the front sight distance shall not exceed 5 meters. 6. Accumulated sight distance difference, 10 meters. When conducting leveling route measurement, there will be sight distance difference at each station, so the cumulative difference of the whole route shall not exceed 10 meters. 7. The difference between black and red surface readings shall not exceed 3 mm. When carrying out leveling measurement, the black surface starts from 0, while the red surface starts from 2 readings. One is 4.687 and the other is 4.787. That is to say, when we read the middle wire reading of the black surface, the middle wire reading of the red surface is theoretically equal to the middle wire reading of the black surface plus the starting reading of the red surface, but due to certain errors in our observation process, the actual readings may not be equal, so an error of 3 mm is allowed. 8. The difference between black and red surface height difference shall not exceed 5 mm. We know that the height difference is equal to the rear view middle wire reading minus the front view middle wire reading. When carrying out 4-level leveling measurement, the black surface has the front and rear middle wire readings, and the black surface height difference is calculated. The red surface also has the front and rear middle wire readings, and the red surface height difference is calculated. In the observation of a measuring station, because the vertical point position has not changed, the height difference will not change, but due to the factor of our reading error, the two height differences we measured are not completely equal, so the limit is less than or equal to 5 mm. 9. The difference between return, attachment, or loop closure is positive and negative 20 root L on flat land, and positive and negative 6 root N on mountainous land. Then, we will learn the burial of leveling points and the layout of leveling lines. Leveling points should be selected in places with hard soil, easy to preserve and use for a long time. The interval can be determined according to actual needs. In general areas, one leveling point should be selected at about 1-3 kilometers, and in factory areas, less than 1 kilometer is appropriate. Leveling points should be buried with ordinary leveling markers or set up as temporary leveling points. The plane control points of buried stones can also be used as leveling points. In order to facilitate finding, leveling points should be recorded. Leveling lines of 3 and 4 levels can be laid out as attached leveling lines or closed leveling lines according to the situation of high-level leveling points and topography of the survey area. When selecting leveling lines, the existing road network should be fully utilized and the lines with smaller slopes and easy to be measured should be selected. The burial of leveling points and the layout of leveling lines are consistent with the requirements of out-of-grade leveling measurement. Next, we will learn the observation procedures of 3 and 4 leveling stations. The observation of 3 and 4 leveling measurements should be carried out under the condition of good visibility and clear and stable imaging. If the imaging is not good, the line of sight length should be shortened as appropriate. The operation methods of the first station of 4 leveling measurement are as follows. 1. Place the leveling instrument in an appropriate position and roughly level it. 2. After alignment, the black surface of the leveling rod is viewed, and the upper wire, middle wire, and lower wire readings are read respectively after the instrument is accurately leveled. 3. After alignment, the red surface of the leveling rod is viewed, and the middle wire reading is read. 4. After alignment, the black surface of the leveling rod is viewed, and the lower wire, upper wire, and middle wire readings are read respectively after the instrument is accurately leveled. 5. After alignment, the red surface of the leveling rod is viewed, and the middle wire reading is read. The above 4-level observation procedures are often abbreviated as after before, or black red. After the observation results are recorded and calculated to meet the requirements, the instrument can be relocated to the next station for measurement. Otherwise, necessary re-observation should be carried out. The observation procedures of the 3-level observation stations should be after before after, or black red. Similarly, for the black surface observation of the leveling rod, 3 wire readings should be read. For the red surface observation of the leveling rod, only the middle wire reading should be read. Now, the general requirements of the 4-level leveling. 1. Generally, observation is carried out step by step in units of measurement sections. 2. Each measurement section requires observation of even number of stations. 3. In the observation process, the leveling point cannot be put on the ruler pad, but the ruler pad must be put on the turning point. 4. The accessory leveling route and closed leveling route only need one-way observation, while the branch leveling route must be carried out round-trip observation. At this point, the whole content of this class has been explained. I hope that through this lecture, everyone can master the observation steps of 4-level survey and the technical requirements of the first station. This class ends here, and we will see you next class.